9.4, so now we're going to start three-dimensional solids. Oh, first thing, let's go back to this guy. What'd you guys, this bottom one, what'd you guys get for an answer? Anyone want to be brave and let me know what you got? Agree? That is correct, 31.5. My work is kind of all over the place on this. First thing I found this triangle. So one of these triangles, and I know that the apothem is 6. And then I found that this little piece is 2.5, so all the way across is 5. That helped me find the perimeter, which was 40. The apothem was 6, so I found the area of the whole figure. So 40 times 6 divided by 2, which I got 120. Then what I did was, what did I do now? I don't know what I did now. I found essentially this area of these two, one triangle, 2 triangles and a half, 2.5 triangles. The central angles of those. I think it was this right here maybe. And then I found the area of the square, and I subtracted off the portion of the square I needed to, which I did 36 divided by 8, but then I multiplied that by something. So what I got in the end was 45 minus 13.5 and 31.5 something. That made a little bit of sense. Were you guys able to do that on your own for the most part, or with your partner? Good job, guys. Proud of you. All right. So, going on. 9.4, we're naming this 9.4. This is a true 9.4 if you were ever in your book. Three-dimensional solids. So, a three-dimensional solid is comprised of two-dimensional polygons called their faces. The two polyhedrons can be subcategorized as prisms and pyramids. These three right here are actually not polyhedrons. Does anybody know why they would not be polyhedrons? What'd you say? It's because they're made of circular sides. And a polyhedron says that they are made of polygons. Is a circle a polygon? By definition, it's not. By definition, a circle is not a polygon because a polygon has to have straight lines, vertices, and edges. Okay. These two, we have prisms and we have pyramids. So you could have a triangular pyramid, you could have a quadrilateral pyramid, you could have a pentagonal pyramid, you could have a hexagonal pyramid, you could have an octagonal pyramid. So what am I doing? What's changing every time? Very good. The number of sides on the bottom face, what it's sitting on. So you take what it's sitting on, let's say it's a 9-sided figure. What's the 9-sided polygon called? Nonagon. So this will be a nonagonal prism, or a pyramid. Okay? So you take that face that it sits on, that's how you name it. Pyramids always come to a point, whereas a prism, you have the same top and bottom. So this is a triangular prism. You would have a quadrilateral, well, a rectangular prism is what we call that next one. A pentagonal prism, a hexagonal prism. So again, you're naming it by its top and bottom, what it sits on. Okay, how many sides it has, and naming that pyramid, or that polygon. On the following 6, say yes or no to each, whether it's a polyhedron or not, and then name it. Whether it's a yes or no answer, still name it. So go ahead and try that real quick. Yes or no on A? What do we call it? It is a pyramid. What kind of pyramid? How do I know it's a square pyramid? Yeah. B, yes or no? What is it? C, yes or no? Yes. Do you guys know what this is? It is a triangular prism. Yes or no on D? What is that guy? Yes or no on E? And it is a? And yes or no on F? How many sides? 1, 2, 3, 4, 5, 6, 7. So what do we call that? Hexagonal prism. Any questions on that, guys? Okay, next page. Parts of a polyhedron. We have faces. Faces are the two-dimensional polygons forming the polyhedron. Edges is a line formed by the intersection of two polyhedron faces. And then we have vertices, which is a point where three or more edges of a polyhedron meet. Okay. Euler's theorem. So this is Euler's theorem. Euler's theorem says that for any polyhedron, the number of faces, vertices, and edges are related by the following formula. The formula is if I add the faces plus the number of vertices, that is equal to the number of edges plus 2. Okay, so for instance, let's try this. Find the number of faces, vertices, and edges for each of these. So this one, how many faces does it have? It does have 5. Has a front and back, side, bottom, up. How many vertices does this guy have? So vertices are my points. Yep. And how many edges? So lines? I have more than that, I think. Yeah, I'm getting 9. I'm getting 1, 2, 3, 4, 5, 6, 7, 8, 9. You guys agree or disagree? Okay, so let's do this. Faces plus vertices should equal edges plus 2. What's 5 plus 6? And 9 plus 2? So a good way to check yourself on this homework to make sure that you have gotten the number of faces if they ask you questions like that. Go ahead and do B and C real quick. On B, how many faces do I have? 8. How many vertices? Edges? 18, is that what you said? So 8 plus 12 is equal to 18 plus 2, and that is congruent. So that's 20 and 20. Very good. What's this guy called? Hexagonal prism. Okay, next one. How many faces? How many vertices? How many edges? So 7 plus 7 plus 12 plus 2, that is, equals, not plus, and that is true. What do we call this guy? Hexagonal pyramid. Last concept in this section is a cross section. So if I took a solid, so if I took a three-dimensional shape like this, so what would this shape be called? Rectangular prism. Taking a cross section is cutting through it, cutting all the way through it, like taking a knife and cutting through it, and seeing what shape we would get. So if I took this three-dimensional shape and I cut through it at an angle right here, all the way through, what shape would I open up? Not a triangular prism. Think about if it's Play-Doh and you cut it and you opened it. It would give you a shape on this side and a shape on this side that you cut, and it would be a what? A rectangle. I should have brought in Play-Doh for us to do this. Maybe we can do that on Monday. Okay, so describe the cross-section of each image below. So a cross-section is an intersection of a plane and a solid, categorized as some polygon. So the plane is like the sheet of paper or the knife cutting it, okay? So if they are doing a cross-section, these are kind of hard to see sometimes. They're doing a cross-section through the center. What shape am I going to cut? When I open it up, what shape am I going to see on both sides? This one's going to be a pentagon. On this one, if I take that sheet of paper and do you see where they're cutting right down there diagonally, what shape will it open up to be? Oval, Circular, yeah. Okay, and then the last one. If I take and I cut that shape where they're showing you, what shape will it open up to be? It is a rectangle. Have you guys ever done that? Like create a shape with Play-Doh and then take like floss and cut it? No? Okay. All right. So what I want for you to do now, we're going to go ahead and we're going to do 2 sections of notes today, but we're going to take a little 5-10 minute break in between. And during that, it's not really a break, you're going to be working on stuff. During that time, I want for you to do page 6 in your supplemental packet. Page 6, that is the continuation of the area of regular polygons. So go ahead and do page 6. You can work with your partners if you would like.